Hello everyone and welcome to Integrated Study course. In this course we are going to discuss several topics related to reverse engineering and 3D printing. I created this presentation for you so you can have an idea about how to progress in this project and step by step, and what are the course structure based on weekly activity. So let's start the presentation. First of all, I would like to introduce myself. My name is Hussam Freij. I've been working in the industry and in education for the past 20 years, and I will be the course leader for reverse engineering and 3D printing. It is a 6-week project. The duration of this project is 6 weeks. So in case you need any questions, you can email me in h.freij@elporo.ac.uk, or you can visit my office at T212. So the course aim, this is 6-week course, will introduce you to the existing exciting world of reverse engineering and 3D printing, and to explore how these technology work together to create innovative bike accessories. So what I'm going to do in this course, I want you to create for me an accessory so you can attach it to the bike. You will learn how to take an existing 3D printed object, analyze it, and then transform it into useful functional accessories for your bike. So first of all, I'm going to give you a part, and then you need to create this part and make accessories. As you can see from the picture, there are lots of ways that you can integrate accessories into the bike. Okay, so the course structure. Week 1, I will introduce the course. I will give you a course overview and learning objective. I will introduce you to engineering, reverse engineering and 3D printing. You need to understand, and I will explain what's the relationship between reverse engineering and 3D printing. And I will introduce also to you safety protocol for using metrology lab and 3D printing lab. And then part distribution, which is the important aspect here. The part, each student will receive a randomly assigned 3D printed part hidden inside a box to ensure that fairness. So this will be basis for their reverse engineering design project. So what I'm going to do, I will bring a box with me, 4 boxes or 5 boxes, based on the number of groups that we have. If we have 4 groups, I will bring 4 boxes, and I will hide 3D printed part in each box. In this way, I will guarantee that it's fair for everyone. So you are not going, as an example, you are not going to receive part that's complicated, and your colleague will getting a part that's easy, could be, as an example, transform into some kind of accessories. So everyone will pick random parts. Okay. For week 2, the reverse engineering and data collection. What you are going to do, student will be divided into groups. Let's say we have 4 groups or 3 groups, whatever we have. Some of the students, or 2 groups, let's say we have 4 groups. 2 groups will go to the reverse engineering lab, and 2 groups will go to the 3D printing lab to do 3D scanning. The aim of this week to collect data, so you can reverse engineer, and you can, the part that I give you, the 3D printed part that I give it to you at the beginning, I want you to model it and able to collect data for that part, measure it using either metrology lab, the normal measuring tools like CMM, caliper, depth gauge, and radius gauge, or using 3D printed lab. So you will swap. The student will swap. So as an example, 2 groups will go first to metrology lab, and then 2 groups will go to the 3D scanning lab after that. Okay. You can use whatever technology that you like to gather the data and to create your model. I will not ask you, I will discuss with you, and you should show me in your presentation later what's the difference between 3D printing and metrology, and which one of these technology you have chosen to create your model. My advice to you to take photo as much as you can, because this will be part of the process and part of the presentation. You need to include it in your presentation. So week 3, building the 3D model. Student will utilize the computer labs to build precise 3D model on the assigned part using the collected measurements and scans. You have collected measurement and scans, 3D scans. So now it's your time in week 3 to create your 3D model. You can import either 3D scan measurement into your choosing CAD. For the CAD application, I don't mind using any CAD software that's convenient for you. If you use SolidWorks, Fusion, NX, Inventor, Blender, SketchUp, whatever CAD software that you want to use, you can use. Then create your 3D model and try to be precise and pay attention to details like dimension, tolerances, and surface finish. In week 4, brainstorming the bike accessories idea. What do we mean by this? Each member, let's say you have a group of 5 students, each member will create for me CAD imagination, CAD design, CAD idea. So each group will individually brainstorm and develop at least 5 ideas for transformation their assigned 3D printed part into functional bike accessories. You can see here in this example, this is one, let's say this member created this one, this member created this one, this member created this one, and so forth. So here we have 5 ideas in this week. I need to see either 5 ideas on the computer, Autodesk Inventor, or NX, or 5 ideas using sketches on iPad. If you are very good in Sketch, you can use your iPad to sketch. I don't mind. If you are good in Sketch using paper and you can convey the information to me clearly, so I don't mind using the sketch on the papers. Design constraints. When you are creating these 5 ideas, you should take into your mind, take into account these following criteria. First of all, part resemblance. The new accessory should maintain a clear visual connection to the original part. It has to resemble the original part. This could involve scaling, repetition, modifying specific feature like fillet. You can stretch this part. If your part has, as an example, 1 attachment, you can add 3 attachment, 5 attachment. 1 arm, you can do pattern, rotate pattern, create 3 arms. If you have fillet or chamfer, you can create 4 chamfers, 4 fillet, whatever you want, but you have to maintain the resemblance. Then another condition, bike integration. The accessories must be designed to seamlessly integrated with the bike, either standalone component or as part of large assembly. You can transfer your part either to 1 part or more than 2 parts, let's say assembly, 5, 6, 7, 8, whatever you want. You can create assembly of component that can fit into the bike, or you can create 1 part. It's entirely up to you. Functionality. The accessory should serve practical purpose, enhancing the bike performance, aesthetic, or rider comfort. You can create mug holder, you can create umbrella holder, you can create bike stand, you can create bike tool saver as an example, but it has to serve function. Okay, mud guard, creating attachment to the mud guard, bike mud guard, but it has to serve the purpose. It has to have functionality. Feasibility. Consider the limitation of 3D printing technology and material available. Consider what are the table of the 3D printer. You have to take this into account. What are the material you are going to print? PLA. Do you need to enhance the structure? As an example, add ribs or enhance the thickness of the part. Do you need to make it more than divide the part? If, as an example, you are going to make big part, you might split the part into small pieces, let's say 3 pieces, in order to fit within the bed of the 3D printer. And then later you can connect them together to create 1 big part. Okay, so by following the guidelines, the student can explore innovative and practical design solution. Then here, concept selection. In the concept selection, you need to think about why you are choosing, let's say you have five parts, about from five parts, why you are choosing this design. You need to create some kind of matrices, as an example, functionality, compatibility, ease of installation, durability, aesthetic, weight, cost, innovative, whatever you want, or complexity, usability, accessibility, able to be 3D printed, compatibility with the bike, or as an example, safety, weight, easy to manufacture. So whatever you need to justify using any matrix, using any kind of design technique, so you can justify why you pick two design, because in this week the student will need to reduce the number of selection from 5 to 2, okay, and print these two. So all group, as a group, you will discuss the select most promising and feasible bike accessories ideas. Student will begin develop formalize PowerPoint, and then in week 5, student each group will choose two final designs only out of 5 sketches or 5 idea on the computer. You need to pick two and print them and bring them to the class in week 5. So as you can see here, not necessary to be related, maybe some holder or stand for the bike and some holder for the phone, could be two different idea. Then in week 6, which is the presentation day or evaluation day, we call it, the student will bring their bike into the presentation room if you want. Each student will deliver 15 minutes presentation, briefly explain the reverse engineering and process and 3D printed model creation, showcase their shoes and bike accessories design, and explain their functionality, why you selected this design, because in week 6, we will eliminate two designs, you will remove one, and you will will keep only one design. So we remove one design, we'll remove, apart from two, we will select one only. And this one, you will tell me why you selected this one based on what, how it's integrated with the bike. You can, if you can't bring the bike here, you can bring physically attached images or videos. Then after that, after your presentation, there will be 5-minute Q&A questions. I will ask you questions and you need to justify and you need to defend your project. I will give you feedback after that about your part and about your project. It will be verbal feedback during the session and written feedback after that. So if you want to see examples, and these examples, I have good examples and I have not promising examples. So I will start with good examples first. So good project. This is example 1. The student given this part. Okay, the student transform this part into this shape, and later they use it. They add also this attachment and this attachment, so they create, let's say, seat cover from the rain. So this was one of the good example, and the student get good grades. Example number 2, the student giving this part, and they transform it into 1, 2, 3 parts, and the final shape is they attach it to the old mudguard that was broken, and then they managed to connect it to the new one here. As you can see, the attachment they have using, and it also can tilt the angle as per their need. So this is good example. Example number 3, it's not considered as bike accessories, but it's integrated well with the bike. The student given this part and they transform it as simple as this part, which is, you can see here in the wall. If you take zoom here, it is it can catch the bike, its holder. So bike stand, you can put the bike onto the wall in the student accommodation, and they provide video for their work. They show me how they can put this bike here, and it can save place and it can carry the bike. So although this is very simple modification, but they get very good grade because of their creativity and because their imagination, how they can transform, and they keep resemblance the same part. It's look like the original part with small modification. Example number 4 is one also of the good example which I like. The student given this part, and as you can see, the spherical shape in the back, they still maintain it here. And from the top, they created one extrusion down, and they created mirror. So one extrusion from this part, and the other part, mirror here, will have a hole. So they created stand. So if you can see here, the bike is stand alone using this stand. So bike stand, I like it. Example number 5, one of the best also project. The student given this part, the final project is also resembled the original one. This diameter has been decreased, this part has been increased, and so the triangle starting from small become wider. And what they create fully assembled indicator, so they can stop. If they want to stop, they can show light, and if they want to go right or left, they can show you. The good thing about this project is the student, they integrated a really electronic devices or electronic part within this 3D printer. So as an example, they created light, and they bring the light, they created the board, they created the assembly, they attached to wire, they have battery, and you can charge it. It was amazing job. And they show you here what are the changes from here to here. So they are show you circle smaller, mid cylinder larger, integrated circle, remove unnecessary design feature, add extra component. I like. And here they are attaching also button in the handle. So as an example, not only you are this light indicator, it is also giving the light, but also it's showing the light, but also they are attaching handle. So you can press if you want to go right, press if you want to go left, or press if you want to have stop. And as you can see here, this is the video showing the parts. So they are attached wire here. So this is one of the amazing project, and they deserve good mark. Okay, not meeting expectations. Sometimes the student, in my opinion, they waste the chance to get a good grade by not making lots of effort into this project or into this course. This course is easy, but you need to put effort. As an example, in this example, they have little adjustment, not enough changes. The only change I can see that they change they consider it as a face, and they change it from sad face into happy face, and they add like pocket in the back. Here you can see no edges, so they add edges here to make pocket in the back. So still useless as bike accessories. In my opinion, this is huge, this is bulky, and you will not, there is no effort compared to the previous work. I can see that there is no effort. This is maybe 1 hour work, and they've been given 6 weeks to work on this project. The other example is this part has been transformed, I don't know how, into pocket, let's say, or holder for the phone and accessories. So no likeness, not resemble the original parts, no likeness. And even the cut here, as you can see, the acrylic part is extended beyond the 3D printed part. Example 3, little adjustment, not enough changes. They just flip this part upside down, and these two, maybe they put it at the edge, at the edge here tangent, and they created phone holder. For me, it's extremely large for the bike accessories. No one will have this bike phone holder as this size to put it into the bike. Another also example that not meeting expectation, no likeness to the original part. This is the original part, and they created mirror accessories to attach to the bike, and it was loose here, so the mirror was wobbly. It wasn't fixed. Extremely large to bike attachment. No one will fix it. So this is the project. If you have any question, don't hesitate to contact me on my email or come to my office. I hope I give you good overview over the project, and we will discuss furthermore in the lectures. Thank you very much.